Hello everyone, welcome back. This is our final lecture. This is our course summary. So we're at the end, we're wrapping up. I wanted to remind you of everything that you learned in class. Everything that we've gone through, you can kind of just, if it took you a while to complete the class, this will just remind you of some of the important concepts that we covered. So we learned all about code blocks. Code blocks is our integrated development environment. It allows us to edit our C programs. It allows us to execute our C programs. It also allows us to debug our C programs. Debugging is important. It helps find and fix our errors. So we have a nice little tool that we can use to write our programs. Very useful. Code blocks, I like its graphical user interface. It's very user-friendly and very easy to use. We also discussed some of the basic operators in C. Right? These are our logical operators, our arithmetic operators, our assignment operators, our relational operators. Logical operators are like the ampersands and the ors. You can compare information. Arithmetic operators, plus, minus, multiplication, and so forth. And then the all-important assignment operator, which assigns data to variables. We talked about conditional statements. This is where you make decisions in your programs. This is where it's no longer sequential. You may be jumping out of blocks. You may be executing different code based on the answer to a question, whether or not it evaluates true or false. So we also learned about Boolean evaluations or Boolean expressions. We learned about specifically the if statement, how to use nested if statements, nested or else statements. We talked about the switch statement, which is very useful to use when you're comparing constants or a variable. It can eliminate many of the if-else statements if you use a switch. Switch is also more efficient. We talked about how when you use switch, you have to use break to jump out of certain cases. A lot of good information with making decisions in your program. We talked about repeating code, which is related to control flow just like if statements. You may execute a line of code many, many times. You're no longer doing sequence coding. So these are looping constructs. These are different keywords that you can use in the language, such as for, while, do while. The for and the while are very similar. You can pretty much do everything you can do in for, you can do in a while. What they're referred to as is pretest loops. You may execute the body of the loop once, or you may execute the body of the loop many times or 0 times. The do while loop is specifically different because it's a post-test loop. The condition for checking is at the bottom of the loop. So you're always going to execute that loop at least one time. It's very, very useful to be able to repeat your code in a program. We also talked about arrays, another very important concept. Arrays allow you to have group data together based on a data type. So instead of creating 10 variables of type int, you can create one name of int and it can store 10 elements. So an array has special syntax with the square brackets. You identify the size. There's a way to set initial data to an array. We also talked about multi-dimensional arrays, which is essentially a matrix or a spreadsheet. It's an array that contains rows and columns. We moved on to talk about functions. C is a module language. C is organized around functions. Functions is a way to reduce duplicate code. You can invoke the name of something, and then the name can contain a group of code that you want to execute. We learned all about the syntax for functions, how you can return data from functions, how you can pass data to function. So we learned about call by value versus call by reference, arguments and parameters, declaring function prototypes at the top of your file, which is useful. We talked about debugging. Debugging, invaluable. It's really problem-solving techniques. It makes you become a better problem solver. And when you write code, problem solving is an essential skill. So when we talked about debugging, finding and fixing your errors, we talked about specific concepts related to it, such as the call stack, where you can identify if your program crashes, where it crashed, by what different functions are invoked. We talked about common mistakes in your C code, whether it's not initializing variables, or missing semicolons, or missing brackets. And then we follow that up with understanding compiler message. You may understand some common mistakes, but if you don't understand the compiler and what the compiler is telling you, it's really, really hard to debug. So we talked about the specific errors that the compiler tells you and how to interpret those errors. We moved on to structs. Structs are a big, important concept. They're similar to arrays, but structs are even more powerful because structs allow you to group specific elements with different data types to a specific name. So we used examples like time and day structs, which allowed you to store like hours, minutes, and seconds. Also dates like years and so forth. But structs are great. Use the struct keyword. You can group together different variables of different types and refer to it in your program. It's almost like defining another data type. There's specific syntax on how to initialize structs. We also talked about nested structures, structures that contain structures. We talked about using pointers in structures. And character strings we discussed. Character strings are basically arrays of characters. There's different operations you can provide on these different character strings. A lot of different string manipulations functions through the string.h. We talked about the basics of these different character strings. And then the most important concept in the course, pointers. And the most difficult concept in the course, but a very, very useful concept. It's important to understand pointers. Pointers are essentially a variable that contains an address. Pointers allow you to allocate memory dynamically at runtime. Pointers are essentially allowing you to manage and manipulate your own memory. There's no garbage collector in C like there are in a lot of other languages. We learned how to define and use our own pointers using the asterisk syntax. We also learned how you can pass pointers to functions, which now allows you to do essentially pass by reference. We talked about pointers and arrays. We talked about how pointers, character pointers are essentially character strings, character arrays, and their similarities. We talked about mallocing data, which is allocating memory, freeing data, and we also talked about pointer arithmetic, which is really, really great notationally because it allows you to go through a character, different spots in memory very fast and in nice notational convenience. You can reduce the amount of code that you write. But pointers, again, most important concept in the course. Really, really have to study these because it is very, very confusing concept. Pointers tend to get abused quite a bit in C, either not allocating memory appropriately or freeing memory or pointing to the wrong memory address or going out of bounds of arrays or out of bounds of your memory locations. Most important C programs, actually all important C programs, are going to contain pointers. We learned about the preprocessor, not a ton, but information about defining constants and using the include directive to include other header files so that you can reuse code provided by the C standard library. And also creating your own include files if you want to reuse functions that you wrote. Input and output. This specifically had to do with reading command line arguments in your program or utilizing scanf to read from the keyboard or printf to display output to the console. Printf is great to use for debugging. Scanf is great to read input from the user. Most programs will ask the user for data, so scanf is the way to do it. And then command line arguments, passing in data to the program from the command line. This is closely related to file input and output. We learned how to read and write to files. Files allow you to store persistent data. Most important programs in C, you need to store a lot of data, and you need to have it there when you reboot the computer. This is what writing the files and reading from files to. And we learned a lot about important functions provided by the standard lib header. fgetc, fgetS to write strings, write characters, and then file formatting functions like fprintf and fscanf. Very, very nice. We learned about the standard C library, mainly the string manipulation string functions, but we also discussed the math functions used for arithmetic, utility functions for getting environment variables or for exiting a program, and then the standard header files that are used in most programs, like limits.h and some of these other nice ones. And so the outcomes of the course, what you should now understand regarding C. You should be able to write beginner C programs. If you can't write a beginner C program at the end of this class and you've studied everything, then I have failed as an instructor. I hope that writing basic programs is second nature to you by now, but with programming, it all takes practice. You have to practice and you have to write a lot of code, and you're going to get better and better as you go. You're able to now write more efficient and high quality C. Throughout the course, I tried to focus on high quality code. And what this means is allowing your code to be easier to maintain, easier to find and fix bugs. You know, when you release a program to a customer, that program may be out there for 5-10 years. You may add new features. You have to fix bugs. And so you want to make sure your code is of high quality. What this means is your code should be modular. It should be organized around functions. Your functions should be cohesive. They should have a single focus. They shouldn't be doing 10 different things. You shouldn't have functions with 1,000 lines of code in them. If you have a function for reading input, have it read the input. Don't have it print output and do all sorts of other things. Modular programming is very, very important. And luckily, C is organized around functions and supports this. You want to make sure your programs are have low coupling. What this means is they don't have a lot of dependencies. You're not depending on using global variables, or you don't have a function that's using a global variable. Coupling, the more dependencies that you have, and if you have tight coupling, it's harder to debug your program because now an error can occur anywhere. If you limit your coupling, it's easy to isolate those errors. Coupling, again, can come in the form of functions that are working together too much with global data. It also means that you may have more dependencies in your other header files and so forth. And then in addition to writing high quality C code with implementation, you also want to make sure you make your code readable. And what this means is you have good naming conventions. If you create a variable, don't create the variable with the name x1 or p1. Use a meaningful name, that what the variable is actually storing. If it's storing data related to employee ID, create the variable name with employee ID. If you're creating a function that adds two numbers, name the function add. Common sense type stuff, which makes your program much more readable, which again makes the code easier to understand. In addition to using meaningful naming conventions, you also want to provide indentation for any blocks of code. It makes the program easier to follow. If you had all of your code with no new lines and no indentation and just a bunch of lines, it would be really hard to follow. So use indentation and use spacing and new lines. You're also able to debug and be a better problem solver at the end of this course. You understand how to use the debugger and code blocks. You understand compiler messages. A vital, essential skill for every programmer is problem solving and debugging, finding and fixing your errors. Also, you can use printf statements to find errors as well. You now should understand the fundamental aspects of the C programming language. Everything we talked about in this lecture and all the lectures throughout the course. And so what I want to say to you is congratulations. Be proud of yourself. The C programming language is not an easy programming language to learn, mainly because of pointers and your memory management flexibility. So you need to pat yourself on the back. You did a great job. You got through the course and you learned a lot about a difficult programming language. This is going to help you become a better programmer in the long term. It's going to allow you to easily learn other languages because a lot of the languages are based off of C. So be proud of yourself. I hope this helped you with your confidence in terms of the ability to write the code. You don't have to be a rocket science to be a programmer, and I hope that this class and that you finishing helped you with this. Now, I also want to mention that don't hesitate to ask questions, whether it's feedback via the ratings or whether it's constructive criticism. I'm here to answer your questions. So just because you've gone through the entire course and listened to all the lectures, it doesn't mean that you can't ask me for help on if you're writing other programs or you're having other difficulties with other concepts. Send me feedback, ask questions, and I'm always looking to improve the course. And for that matter, if you think that maybe one of the concepts wasn't adequately explained, let me know. I can write some more lectures or try to improve on it. I'm always looking to improve the course. I'll make course updates throughout the class to improve it, so feedback is important. And last but not least, I want to thank you for signing up for the course. It means a lot to me. I put a lot of effort in this, and so I appreciate that you signed up for the course. And again, my hope is that you learned a lot. But pat yourself on the back, and thank you very much. Good luck.